So let's start with this. I've got a biased coin that is a 3/4 chance of getting heads. You are going to toss it 90 times. Let X be the number of heads out of 90 tosses. Can we find the mean and variance of the distribution? Now they have already defined it for you. We just identify correctly. Number of heads out of 90 tosses. The trial is actually the toss. Okay, although here they have phrased as number of hits. Hits is actually the condition on the toss. Okay, so they sort of phrase it differently. If it were me, I would have defined it. Let's say we solve an exam problem. I would have defined as number of tosses out of 90 tosses that are hits. Okay, I think it's clearer that way. Okay, but they may phrase in this manner. We just need to identify correctly. So trial is your toss. Success is referring to your hit. Okay, what is the condition on the toss, which is a hit? We write in the distribution first. Since they have defined, we will just write the distribution. So it's 90 and 3/4. Let's get the mean and variance. So we check EX and P and variance is NP times 1 minus P. What does this imply in the context of the problem, these two numbers? Your mean is saying that on average, when we do the 90 tosses, over a long run, I expect that the average number will be 67.5. We should get that number on average if I do it many rounds for the 90 tosses. And variance refers to the spread. The spread of this result is 16.875. To understand spread, okay, let's just draw a simple number line here. You know that the values always fluctuate in the sense that you do 90 toss, you may get, say, 60 hits, 70 hits, and so on. The value fluctuates. But I know that even if it fluctuates, the average value is going to be about 67.5. The number of hits will surely change for every 90 tosses, but it will be having average at this number. And spread refers to the fluctuations. Variance is referring to the fluctuation of the values. You want to think of it something like it is going to fluctuate around plus and minus 16.875. Okay, very roughly and briefly, this is how it should be visualized. Okay, the 16.875 is a fluctuation or a spread from the expectation. Then we go to part 2. They are looking for most probable number of hits. You may recall that last lesson, the last portion, there is this most probable also, but that was a hence question. This is not a hence. There is an easier method to do it if it's not a hence problem. We try to understand what's most probable first. Most probable X value refers to, can you give me the X value that comes with the highest probability? So there are many different X values, but give me the one that will have the largest number, highest probability. Which means you're supposed to check. Remember, a binomial variable always starts from 0. It then goes to 1, 2, all the way to n. So for this particular binomial variable, what we are looking at here is which is the X value that has the largest probability. We will use the graphing calculator to help us. Okay, so that X value with the largest probability, you want to know that it's always around expectation plus minus 1. So in our context, I know that the expectation is 67.5 plus minus 1. Around those values. So what should we do when I go for the graphing calculator? You must know which to pick. You should be picking PDF because you are checking for equality. I want to know equals to 0, equals to 1, and so on, which is the highest. So you want to make this value become the variable in your table. How do we put that as a variable? So on my binomial PDF, this is the unknown that you want to set. Set it at x value because you want your x value to change from 0, 1, 2, 3, and so on. So x value is set as x. We put into binomial PDF. And there is this special screen that we are doing here versus what we had just now. I went to second window. There is this settings that you want to access. When I go to second window on the table settings, you can choose which value to start and what is the change. Why did I go here? It's because I don't want to scroll through. I know that the answer is around 67.5. So I don't want to keep scrolling on the graphing calculator to go to 67.5. I wanted to start straight away at 64. So that when we go and see at the table, we will be comparing these three numbers. Look around 67, 68, 69, and aim for the highest. Highest is at 68, the largest possible probability. So once you obtain that highest number, you can just conclude, therefore, the most probable x is at 68.